Hi and welcome to another video. In this video we are going to solve count good nodes in a binary tree problem from the Leetcode. In this problem they will pass pointer to a root node of binary tree and we need to return number of count of good nodes. A node is considered good if there are no nodes with higher value from root node to that node path. If you consider this first example, root node will always be a good node because that is the only node which is present in the path from root node to that particular node. So root will always be a good node. And if you consider path to node 4, there are two nodes 3 and 4. So there is no node which is having a higher value than 4. So 4 is also a good node. And if you consider this node 5, the path is 3, 4 and 5 and all the values which are present in that path are lesser than or equal to 5. But if you consider this node 1, the path is 3, 4 and 1. So there are some values which are greater than 1. So 1 is not a good node. And if you consider this node path 3 and 1, there is already a value which is higher than 1. So 1 is not a good node. And if you consider this node 3, the path is 3, 1 and 3. There is no value which is greater than 3. So 3 is also a good node. The approach for solving this problem is quite simple, even though it is rated as a medium problem. What we can do is we can travel the tree and we can keep count for good nodes. Initially good nodes count will be 0 and then we can write a function which will be inside this class travel of root, and we can return the good nodes count. So along with this function we need to pass what is the current max value, because this is the only thing we need for deciding whether a node is good or not. So we need to initialize current max to a minus infinity, or we can consider what is the input range values. So here they have mentioned that nodes value range from minus 10 power 4 to 10 power 4. So we can initialize our current max to minus 10 power 5 instead of infinity. We need to implement this travel function, which is very similar to tree traversal. So travel of, it will get, since it is part of the class, it will be called with a self object self, and then we get a root, and then we get a current max. Here first we will check if root is null. If that is the case, we will just return. Otherwise we will check whether our root dot value is greater than or equal to all the values till that path. If this is the case, then this is a good node, so we need to increment good nodes count by 1. So we will increment the count and we will update current max, because value which is present at the current root node is greater than the current max. So we will update the current max and then we will travel to the left and right subtree, that is root dot left, and we should also pass current max value. Then we will travel to the right subtree. This travel function is very similar to pre-order traversal. That is, we are processing the route and then we are going left and right. So in between, while processing the route, we will check whether all the nodes we have seen till that root node, whether they have a value which is greater than or equal to current max. If that is the case, then we can increment the good nodes count, and finally after going through all the nodes, we can return this count. Let us submit this solution and check whether it passes the initial test cases or not. Okay, since it is part of this class, we should use it with self. Yes, as you can see here, this solution is passing the initial test cases. Let us submit the solution and check whether it passes all the test cases or not. Yes, as you can see here, the solution is passing all the test cases. The solution is very similar to tree traversal along with the current max variable. Thanks for watching this video. If you are interested in learning more about other data structures and algorithms, you can check out other videos from my channel.